Hey everyone, today is Monday, October 21st, 2024, and this is your forecast analysis for severe weather in the Central Plains, given a slight risk of severe storms for central Kansas and areas of Nebraska, given the SPC has given an area of 2% of tornadoes for central Kansas and 5% of hail, 5% of wind, and 15% of hail. Looking at our radar right now, we see currently strong thunderstorms ongoing in central Kansas. This is just like the first round. This is just going to be the first round of storms ongoing, and a second round of storms is expected later in the next few hours. You see, here's our ongoing storms right now, but back here behind it, you see we have an area of cumulus forming. So we have another. We currently have a Pacific front right now that is going to be as this Pacific front starts moving to the central Kansas area, that's going to be causing our storms to intensify in a second round of storms in the later afternoon. Currently at our 500 millibar level, you see here's our upper level disturbance, here's our upper level low, and here are ongoing storms right now from this trough right now. Going down to the surface, you see right now we have a surface low in northeastern Colorado, and a Pacific front is coming off of it, and that's going to be creating storms in this area behind our current line of storms right now. You can see this better in our surface observations. Like I said, here we have winds going here. So we currently have a surface low right here in northeastern Colorado. And if you saw my video from our New Mexico storm, you can see that I have a kind of a checklist of forecasting. So first, we're going to be looking for areas of rising air, which is going to come from divergence in the upper atmosphere or convergence at the surface. Now, from boundaries. Now, like I said, we have a Pacific front, so that's going to be our boundary for today. You see winds coming from the west, currently in Colorado, and winds coming from the south here. So, and we have dew points behind it in the 30s. Right here, we have dew points in the 50s. So here's going to be our Pacific front coming off our low. So the warm side ahead of it is going to be our area of storm initiation. So here we have a boundary, which is creating convergence. So that's our first check. We have convergence from a boundary. So we have a cloud/rising air. Now, our forecast soundings is what's going to give us the information for these other ones. So we check our forecast models. Here's the NAM at around. Here's what NAM depicting. Here's what the NAM is depicting in the next few hours. Here our surface, our upper low is going to be moving off to the east a little bit. We go down to the surface. You can see here is where our Pacific front is going to be. We don't have that much. We don't have a big of a warm sector. You know, we're barely at 50s dew points. So area with higher dew points is going to be conducive to more severe weather. But right now, here's going to be our boundary. We're going to have winds coming from the west, and then here we have winds coming from the south with higher dew points. So here's our boundary. So this area ahead of it is going to be what's conducive for stronger storms. So let me take a sounding maybe here ahead of it, and let's start checking off some of these. So thunderstorms, we need deep moisture, adequate lapse rates, and instability. So deep moisture, we have 56 dew point at the surface but it's deep that it's extending up into 1 kilometer up into the atmosphere. So we have deep moisture here. Here are our lapse rates, the rate of how fast the air is cooling the higher you go up into the atmosphere. So at the surface, we're going to have a 78 temperature, but up here, we're already at freezing level. So we're going to have a very quick rate of change from the surface to the 3 kilometer level. We're going to have 8.5 centigrade per kilometer. And at 700 to 500, so around from 3 kilometers to 6 kilometers, we're going to have a 7 centigrade per kilometer. Anything over 6.5 is considered unstable. So we're going to have rising air moving into an unstable atmosphere. And here we're going to have, here are Kate values. This number is quantified into instability. We're going to have instability in the thousands, 1,100. So this is good instability. Rule of thumb is anything over 1,000 is good for possible tornadoes later on. But at least for thunderstorms, we have a environment conducive for thunderstorms. So you have to check on that. We have deep moisture, adequate lapse, an unstable atmosphere given our lapse rates and our Cape values. So we have an unstable atmosphere conducive for thunderstorms. So that's a check on this. Now, supercells is measured by our deep layer shear, which shear is the rate of change, is a change in wind speed direction and speed with height. So here at the surface, we're going to have southwesterly winds at 15 knots. Meanwhile, at 6 kilometers, we have more westerly wind at 50 knots. So we have a change of 15 knots to 50. And here's our deep layer shear levels of 42 and a 49. Anything over 30 is conducive for rotating thunderstorms, aka supercells. That's longer-lived thunderstorms that are rotating in the mid levels, not at the low levels only, but primarily rotating at the mid levels, conducive for more severe weather. So yeah, so these thunderstorms are going to be moving into supercells in this environment. Now, finally, checking our tornadic supercell characteristics, we have to check for low cloud bases, low level instability, low level shear, and curved photographs. Now, checking our low cloud bases, that's how far away the bottom of the cloud is from the surface. So if this is the bottom of the cloud, and here's the surface of the Earth, the closer it is to the ground, the better you have a chance for supercells turning into tornadoes. Now, the way you check that is here's your low level, your lifted condensation level is where the bottom of your cloud is. Your EL, your EL is your equilibrium level. So here's your cloud depth, and your LCL, here it is in numbers, is at around 13,000 meters, which is low enough for tornadic development. So we have low cloud bases. That's a check. Now our low level instability is instability in the lowest 3 kilometers. So this area, and that's aka 3 Cape. And this is average Cape of your whole environment. But the lowest 3 kilometers of the atmosphere is for tornadic storms. And here it's measured in 3 Cape here of 89. And anything over 50 is better for tornadoes. So I have to check on that. We have 89. So we have low cloud bases. We have low level instability. And the next thing I had to check was low level shear. That is measured by this numbers over here. This is usually you want these numbers higher. So the fact that they're usually you want these numbers in the hundreds. So like 100, and this one you want it like a 200. And given that they're 59 and 124, that means that this environment is not going to be as conducive for tornadoes. It's not impossible, but it's not as conducive. So given that we have given that we have we're going to have supercells that are not going to be in a highly sheared low level environment, that means that this uh, sounding that I took in central Kansas is going to be more conducive for hail instead of tornadoes, which is why the SPC outlined more 15% chance of hail and just a 2% chance of tornadoes. Now, that's just one sounding that we got. That doesn't mean that there's not going to be any tornadoes. Like I said, we still have, if we move for a little bit more east, maybe let's check here. This it's just like a trade off. Here we have better shear, but we have weaker low level instability. So this is also more of a hail environment. So that's why we have just a 2% chance of tornadoes here going up to Nebraska. If you check, let's see, going up to Nebraska, let's see some soundings up here. Yeah, and it's more of the same. You have nice low level instability, nice lapse rates, nice instability. We have deep moisture, low cloud bases, but we have weak low level shear. Like I said, you want this in the hundreds plus, and the fact that we don't have it at that means that this is more conducive for a hail environment. But sometimes Mother Nature does what she wants, and given that we have high low level instability, that might be adequate enough for maybe a brief tornado in this environment. This is this morning's HRRR. It gave the storms that are ongoing right now, the thunderstorms, but then here is our when the Pacific front reaches a warm air here, that's when it starts giving off these supercells going off. So we take a sounding near this one. It's highly contaminated, but it's giving more of a hail environment than a tornadic environment. If we check the RFFS, same similar thing. We have the thunderstorms going on right now. And then the next few hours, we have supercells that are more conducive for large hail than tornadoes. But given that in some models we have good low level shear, and in most of the models we have curved hodographs, which is indicative of low level rotation, which is what I included here. We have curved hodographs is something we look for. And here, like curved hodographs means this thing at the low levels is more of a R shape, which is what it is right here. And that's why there's a 2% chance for tornadoes, but a larger chance for hail. And that's your analysis for today's severe weather event in the Central Plains.